with the appearance of new architectural styles for web APIs over time, their description languages also knew a certain, I don't know how to call it, appearance also. And almost about 10 years ago, we started seeing the appearance of some very interesting description languages for the APIs, such as Swagger, or known today as OpenAPI, Rumble API Blueprint, that I summarize in this table here. So OpenAPI is one of the most popular description languages among developers, and of course, all the other languages has a common purpose, which is like to help developers or OpenAPI designers to better capture their design decisions. So, for OpenAPI, the descriptions can be written either in JSON or YAML, and the last stable version of this specification has been in 2021. And then what is really interesting about this language is that it can serve as an input for client and server code generation tools and also documentation generation tools. So the OpenAPI specification comes in two versions, the second version and the third version, and which are slightly different of each other's, and they are both allowing to describe in details the different endpoints and operations provided by a certain API. And also, they allow to describe in details the data formats supported by a specific API. So actually, these files have been exploited by a set of works for different purposes. In our case, we want to exploit them. We want to exploit these detailed descriptions folded in these definitions for another particular purpose. So what we want to do is that what we are doing currently, actually, we are digging into these documents in order to detect and extract common structures used by Web APIs designers for solving specific problems, or what we are going to call here structural patterns. We want to do that for two main purposes. The first one is in order to capture design decisions made by developers in currently available APIs. And actually, why we also want to do that? Because knowing how currently available APIs are designed can help us to build a kind of data set of building blocks that can be implemented in support tools dedicated for web APIs design. So as a first step, we went to GitHub, and there is a lot of publicly shared repositories there. So we went and we searched for these files. We collected a large data set and we filtered a lot, and then we ended up with 6,619 API definitions, or open API definitions. I call them here definitions because a definition can be in one or several files. So in this chart here, we can see the yearly distribution of these files that we have used at the end. And we have noticed that the majority of the files were in the second version of the OpenAPI specification, while the rest is in the third version. Then we have validated these files just to have an idea about their conformity to OpenAPI specifications, and also the common problems that developers can make using this specification. So we have noticed that around 40% of these files were invalid. And in our for what we want to use these files, being invalid doesn't really make us do not use this file, because our purpose is to use it. So as long as we are able to extract from them what we want, we consider them valid for us, and then we use them, so we won't throw them away. So just to give you an idea about the different characteristics of the APIs that have been described in these files, for example, the sizes of these APIs were kind of different, and the majority of them having almost sizes that are smaller than 200, and just few ones that are having a size over 200. Here, when I talk about a size, I mean exactly the number of operations provided by this APIs. And we wanted to know how much is the different providers of our APIs. So we went and tried to extract the name of the provider, and we have extracted, for instance, just from almost 20% of the APIs, their providers, but for the rest, we couldn't do that automatically. So, for instance, I can show you here that we have some very known like providers, such as Google, for example. 474 of the APIs in the dataset are of Google, and we have other like providers that are either famous or not famous. So, as a picture is worth than 1,000 words, so what we wanted to do with these files, first of all, is to be able to visualize them in order to have an idea or a way to rapidly understand what this API is doing. So we took each file and then we did, by means of a model transformation, we transformed these models described in OpenAPI specification to another model that we are able easily to visualize it as a tree. So here, for instance, if we go to the OpenAPI file, all the paths are listed as a list, while in our like visualization or in our model, we represent the paths are a set of path segments. For example, here, each branch from the root until the method is representing a specific path or a specific operation, where the nodes here are representing the path segments. The white nodes are for static path segments, and the black ones are for parametric path segments. And the leaves are simply representing the HTTP methods. Just to show you another example of another representation of a real little API. So here we can notice that, for instance, this API is almost all composed by this little fragment here, which is repeated for this one and this one that I collapse here. And the rest one fragment here is not too much different than the previous ones. It just has another get operation here. This is another example of another API. So we don't have only the black nodes and the white nodes. We have also some gray nodes that we dedicated for these path segments that has some notations that we are not used to and that they are not supposed to be like that. So we painted them in gray. For instance, if we go to see why this label on this node is like that, we can go to the original OpenAPI file, and then we will notice something is that actually this post operation here, if we read the description of it, it is used as for fulfilling the role or of get operation where the parameter is sent on body. So if I collapse here these branches, you can notice that it's kind of the API is being transformed to a RPC-like style API. And when I went to look at the history of this API, I realized that actually there was a kind of transformation in the style that has been followed for designing this API. It started by being an RPC-like, and then the developers or the designers started introducing some specific methods for what they want to do. Okay, so here I would like to introduce some concepts that will be appearing a lot in the rest of these presentations. First of all, we have the API. So the API here is represented by the OpenAPI specification definition. Then we have transformed these APIs to another tree model that we are visualizing here. And then from each tree model, we could extract a set of fragments. And these fragments are basically just also API fragments. Also, for each tree model, we can associate a tree structure, which is just an unlabeled version of the tree model. So we go to the tree and we just remove the labels of all the nodes. For each tree model, we can also extract the set of labels that are labeling the nodes of the tree. And also, the model doesn't only have what we visualize in the tree view, but also it contains some transformed natural language descriptions that we got from the original OpenAPI definition. So for each of these components, we have associated some metrics. The first one is the size. A size of a tree model is simply the number of nodes in that tree. For the API fragments, we were interested on calculating their occurrence and popularity. And then for the tree structure, we wanted to know how many unique tree structures of fragments are appearing in the global dataset of fragments. About the label sequences that we have been extracting from the tree models of the API fragments, we went and we wanted to calculate the semantic closeness of these labels in order to know and define the different contexts of use of a specific tree structure of a API fragment. So, and also we wanted to know like how many distinct label sequences are used for each API of each tree structure of an API fragment. So, as I said before, we had a number of 6,619, from which we could extract more than 200,000 API fragments. An API fragment can be seen also a kind of subtree of the big tree that is representing the API. Then, from these more than 200,000 API fragments, we could aggregate them into 70,000 tree structures, which means fragments that are sharing the same tree structures. And from this number of tree structures, we could extract more than 60,000 labels, unique labels. So we wanted to know actually how is the difference between the occurrence and the popularity of the fragment. The popularity is basically just the number of APIs where a specific fragment is appearing. So we want to know how much is popular a fragment. And the occurrence is the number of times that a fragment is appearing in general. So if we can notice, you can see here, we can notice that some fragments are appearing more than one time in the same API, while the majority is appearing just once in an API. So here we can have a better view, and we can see that the fragments, the most popular ones, are the ones with smaller sizes. The same is for the occurrence, so they have like almost same distribution, just some few cases that are appearing of fragments that are appearing more than once in the same API. So after extracting all these fragments, our goal is to aggregate them into collections. And we have aggregated them in a set of collections that we called also patterns. As initially, now we had just extracted 5 collections of fragments that we will be seeing one by one. The first one is a read-only. So we have detected that this fragment here is occurring more than 1,508 times with more than 700 different labels. What is the role of this fragment? Basically, it just allows to have on both collection and the collection items the read operations. So we can list the items of the collection and read individually each item. So this chart here just show the APIs, like the year of the API, where this specific fragment is appearing. It's like the life cycle of this fragment. And the second collection, we call it enumerable collection. Why? Because what it does, it allows to be able to list the elements of the collection, and it allows also to have some operations over the items. This is a simple example of a fragment that we detected that it was repeated in several APIs. So it just allows our get operation and editing operation over the items of the collection. This collection has 3 variants. The first one is what we saw before. The second one is this one. It allows, in addition to the put and the get, a delete one. But here we can see that we are kind of able to delete items from the collection, but we're not able to append anything to the collection. So we were doubting about how much is really correct this design. For that, we went to check for what actually this delete is used. So for doing that, we went to our models and we checked the description associated to this method. So this is just an example of some descriptions of this method. If we can go here, for example, to unfollow person, this is a description from a specific fragment that appeared in an API. So we realized that there is a way for unfollowing a person, but the fragment is not providing any way for following a person. So for understanding better, we went also and checked the descriptions of the other methods for this fragment. And then we realized that actually the method that has been used for following a person is a put method. So here, the follow is considered as a characteristic of the item and not like another item to add to the collection. So this is an example of an API where this fragment is repeated a lot. So this API is almost only composed by this fragment if I remove this one, and just this one that make the difference. This is the third variant of this collection. It has, instead of a put and delete, a post, which is also a kind of suspicious. So the same as we did for the other, for understanding the goal of use of this fragment or the goal of use of this operation, we went and checked the description of this operation in the original, for all the fragments. So we understood two use cases. The first use case is that actually this post here is used for appending an item to the collection. But actually, if you want to append an item to the collection, the post shouldn't be attached to the item, but should instead be attached to the collection itself. The second use case that we have detected is that this post here is used for updating an attribute of an item. While for updating an attribute for a resource, the put operation is the most adequate. This is the third pattern that we have detected. So this pattern is, we call it appendable collection because it allows an append operation over the collection and then different operations over the collection items. The fourth pattern collection that we have detected is this one. So we can notice here that this pattern exposes the items to different operations. However, it is not allowed to do anything to the client to do anything over the collection itself. So seeing that there is a post here for this variant over the item, it's also kind of suspicious. So we did the same, and then we discovered that also it is used for the same purposes as before, to perform the role of a put operation over the item, or also to append an item to the collection. The fifth and the last patterns collection is this one. So basically, what does this collection contain? It is a set of fragments, variants, that allow both to append and enumerate the items of the collection, and then some operations over the items. So for the first list, we can see that it is allowed just one operation over the items. And then we have another list which allows two operations over the item. And then we can have also, we had some fragments that are allowing more than 3 or more operations over the items. One thing that is more interesting about this fragment here, and if we read it, we can see that it is a very expected result. So it has been repeated more than 1,000 times, and it is also the most repeated fragment that we have found in the whole data set, with more than 4 operations. So here I want to show you an example of an of like a real API that is kind of constructed. Okay, I need to expand this here. Okay, it is kind of constructed by aggregating the sum of the fragments that we have seen earlier. So this one is on the collection pattern. So this one also is a collection pattern. This one, the first one that I collapsed. This one also is a collection pattern. And this one also is another collection. This one is an append. And this one is a read-only. So when I collapsed all these ones, we can realize that the rest is just some trivial get operations over resources. So I can see that just if I knew like that these blocks that I have showed before, they were kind of useful building this the structure of this API. So for concluding, so here I have showed you a study that has been done over a set of OpenAPI specification files in order to extract some structural pattern. So as an initial step, we have classified and extracted this pattern and classified them into 5 collection of patterns. Why did we want to do that? Because we're aiming at kind of building a kind of data set of building blocks in order to be able to implement it maybe in a tool for the supporting the design of web APIs. And thank you. I think I finished here.